Number 9, how many ways can a basketball team of 5 players be chosen from 8 players? Every interim I've seen and the released items from ACT Aspire always have questions like this where it asks how many ways something can happen. That concept is not really one that you've been taught yet, and so I want to go over a couple of things. So if you were to list out all the different ways, you can see I've just started here taking the first 5 of the 8, removing the 5th one and adding the 6th one, removing the 5th one, adding the 7th one. Just did all these different ways of making a team, and I've only started with ones that included the first player, and you can see how many I've gotten already. There's just no way that you're going to be able to list all those possibilities, so there has to be an easier way to do that. And so these types of problems are called combinations or permutations. And the difference between the two is combinations you use when order does not matter, and permutations are when order does matter. So a good example would be like your combination lock on your locker. We call it a combination lock, but it's not really a combination because you have 3 numbers, but you have to do them in the right order for you to open up your lock. And so really what you have on your locker is called a permutation lock, not a combination lock, because permutation order matters. So one way to remember the difference between the two is permutation starts with the word perm. And so if you know what a perm is, if you go to the salon, the hair salon, and get a perm in your hair, there are certain steps to the process, but you have to have them done in the right order, or you're not going to end up with the results that you want. A combination kind of reminds you of the word combo. So if you go to a fast food restaurant and order a combo, it doesn't matter what order they give you those items in or what order you eat them in. And so that'll help you remember combination is when order does not matter, permutation is when it does. So for example, if we had some people competing, we had 10 people competing, and I wanted to know what are all the different ways that those 10 people could be in the top 3 contestants. Well, I'm just saying top 3. I'm not saying that they have to have a certain place. So the order would not matter in that example. But if I had 10 competitors and I wanted to know how many different ways they would come in first, second, and third place, now the order matters. Because if I talk about 3 people here, these are different results here. They're all the same people. They're all the first, second, and third people, and they're all in the top 3 places. But now this is all different results. This one, the first person won. This one, the first person came in third. Here, the third person came in third. Here, he came in second. Okay, so these are all different results if the order matters. But if order doesn't matter, these are really the same thing because those are the same 3 people in the top 3. So order matters is a permutation. Combination is when it does not. Now your calculator, it's a complicated formula for you to do by hand, but your calculator does combinations and permutations. And this is what they look like when they're written out. The capital C meaning combination, capital P meaning permutation. These are subscripts, so those aren't exponents. This subscript, this n, is the number that you are choosing from. So in my little example, I was coming up with 10 people competing. The n would be 10. That's how many you're choosing from. The r is how many you're choosing. And so in my example, I was choosing the top 3. So that would be 3 in this case. So if I was talking about just coming in the top 3, then this problem would look like this, a combination. If I wanted all the different ways they would be in first, second, and third, that would be a permutation, and it would look like this. Choosing 10 on both, and we're choosing from 10 on both, and we're choosing 3 on both. But one is order doesn't matter, one order does. So I'm going to show you how to put those in the calculator. So on your calculator, you have a math button. When you press the math button, these different headings are here. This is a probability problem, so we're going to scroll over to probability. And you will see these 2 things that I've been talking about. Number 2 is for permutations, 3 is for combinations. Now, before you press one of these, you have to put the number that you're starting with, and that's your n value. So you're going to have to go back to the empty screen and type in your n value first. Then you can go to math, probability, press NCR if that's you're doing a combination. And that is that number they're putting in for N. Now you just have to put what number you're putting in for R. So that's how it actually looks on your calculator. 10 NCR 3. But the 10 is the N value, the 3 is the R value. So that would tell you how many different possibilities there are. Now that was not our problem. Let's go back to our problem. Does the order matter on our problem? How many ways can a basketball team of 5 players be chosen from 8 players? Nope, we just need 5 people on the team. We're not saying one is higher than the other. We're not wanting them in a certain order. So this is a combination problem. So we need to come up with the N value and the R value. How many people are we choosing from? From 8 players. So the N is 8. How many are we choosing? We want a team of 5. So our R value is 5. So this is what I'm going to put in my calculator to find out how many different ways there are. So again, remember you have to put in the N value first. So on a blank screen here, I'm going to type in 8 first. Then I'm going to go to math, over to probability, and I'm using the combination, which is number 3. And now I'm going to put in my R value, which is this 5. So this is an 8C5 problem. And there are 56 possibilities. So it'd be really hard to spend our time coming up with all those 56 ways. This is the easiest way to come about that number.